once the time will get over, and then within 10 seconds you are supposed to click submit, so that your quiz will get saved in the Google, and there will be no discrepancy. Because if it is automatically then deactivated, you may lose all the marked answers. Okay, so it's 10:02 as per my watch here.
You will put a timer, sir, on this screen. It's okay, sir. No problem.
Okay.
We are ready, sir. No, you can send a question.
I have released the quiz. So 1 minute buffer I already included in it.
So did you share the link?
Yeah.
We didn't
It's
receive.
on the Google Classroom only.
Okay.
Sir, there is any link? I'm not find any link here. Google Classroom.
I hope you have joined the Google Classroom.
Yes, sir. I have joined it. Here I am seeing only instructions, sir.
No, you will find the Google form.
Just received an email. Just received.
Okay, did you get it now?
Yes, sir. Yes, sir.
Okay.
Sir, I didn't get that. Could you share in chat, sir? Could you share the chat? Could you share the link in chat?
No, you are not able to get it in Google Classroom.
Yes, sir. Yes, sir.
You log into your Classroom account with the IIM Trichy email ID. I hope you have joined the Google Classroom.
Sir, could you share the link, sir?
Oh, still you did not get it?
Yes, sir.
Can you tell me your email ID?
I will share you. Sir, kavala.pgcmma001. Kavala, Kavala, Kavala.
Can you post it in the chat?
Okay, sir.
Kavala NVA, na?
Yes, sir.
Okay, okay. Okay, just check your email.
I got it, sir.
Sir, how many more minutes remaining?
9 minutes.
Thanks.
5 minutes more. 2 minutes more. Okay, time over. Submit the quiz. In 10 seconds, it will deactivate. Quickly submit.
We are not able to submit it. Something.
See, I already told you that, and you exceeded the limit. Okay. 10 seconds was the buffer given already, but then still you are not submitted it. So I can see here, out of 80, 66
We have
have
just
been
submitted
submitted.
now.
Okay, just go to the submit button and click it.
So it's submitted, but showing no longer accepting the response.
So I told you that it will automatically get deactivated. So 30 minutes, 30 second setting was done in that. That's what I asked you, that within 10 seconds you have to submit it.
Can you allow for 1 minute, please?
No, quickly. That's what I told you, that you just submit it now.
Okay. But now we have to select
I
all
think
options.
my laptop
No, just
hang.
submit the button.
Not submit.
Sir, now we have to select all options again.
You just submit the button.
By just submitting, it will be all blank, 0 marks.
See, in next 10 seconds, again, it will get deactivated. So you have to strictly follow the instructions.
Sir, I have submitted before, so but not received confirmation. Then again open. So again blank. All the blank sheet is coming. So can you kindly confirm, Nagendra
No, you
Chandel?
have to be in that page only. Okay. Once the link activates, whatever responses that you have accepted or selected, those will get automatically get saved.
Nee, I have submitted by clicking the submit button, but confirmation was not received at that time. So it was asking the mail ID and the name I have given. Then again the link is open, and go to the again Google form blank. Again I have to select the options or such type
No.
of.
You have an option in that you can resume your quiz if the link is activated.
Link is activated. So acha, there is option to resume quiz. Where is this option? Re- Getting.
Are you getting that option?
No, sir, not getting that option. Where that option is given, I'm not getting. Quiz one. Mark as the. Not getting the options. Can you kindly confirm the name if you have seen here those who have submitted?
No, I
Nagendra
cannot spell
Chandel.
out 73 names.
Okay, no, no, yes. Yes.
But then you have exceeded a lot. Almost 2 minutes it was being kept active.
Mhm.
I'm not able to submit, sir, last 10 minutes because system issue.
Okay, quickly in 5 minutes you submit it. Or 2 minutes. We have already exceeded a lot. 10:29 it's. So whatever you want to tweak it now, just do it and within 2 minutes you submit.
Sir, what about people who have already done it?
No. It will accept only one response. If you are submitted, you will not get it again. So those who have not submitted, quickly submit it within 2 minutes. Okay, in 10 seconds, the link will deactivate. Huh? Just submit it. Okay, I'm closing the link. So I hope the screen is visible.
Yes, sir.
I have shared the screen. Screen is visible. Okay.
Yes, sir.
Okay.
Sir, when will you announce the scores, sir? Scores, sir, for the quiz?
Maybe by tomorrow or after the class gets over, I will check and then I will share. Okay, this will remain here. Huh? Okay. Okay, so today we will discuss about the one of the important aspects in the manufacturing system that is related with the scheduling. And many times there are situations wherein the business organizations are not able to achieve their key business drivers like quality, quantity, cost, delivery, or service, which are considered to be the main drivers in any business organization because of the scheduling problem. So if schedules are not correct, so in that case or in that situation, it may be a case that the business organizations will not be able to achieve these key business drivers. So today we will discuss about the important aspects of the scheduling problem. So what is the need for scheduling? So if we look at the different planning horizons, which we consider as a part of any planning process. So we have a long-term schedule, we have long-term planning, we have a medium-term planning, and we have a short-term planning. So as a part of the planning purpose, any operations management area will require the planning at various levels. So if you look at the long-term level, the long-term decision will be in terms of the kind of a strategic decisions where what will be the location for the plant, in which site particularly it will be located, whether it will be located in Tamil Nadu or in Maharashtra or in Gujarat or in West Bengal. So that kind of a decision is a kind of a long-term decision, because once the facilities are created at that particular location, it's not possible that we can shift those particular facilities. So it's a kind of a long-term decision when we are looking at the planning aspect. Similarly, what will be the technology, what will be the process, what will be the product design. So all these aspects are normally considered as a part of long-term planning. If you look at the second level of the planning, that we call it as a medium-term planning, which is normally for 1 year to 2 year purpose, or this is also called the aggregate planning. So normally long-term planning is considering almost 10 to 20 years, but of course it depends on the product life cycle. Whatever the long-term planning that you have done, arrange the resources for the, or plan for the resources for the particular operations. So based on that, we have an aggregate planning wherein we plan for 1 year or maybe 1 to 2 years, depends on the product and what kind of product life cycle that product will be having. For example, we cannot compare the product life cycle of an electronic equipment like a mobile phone with the other particular product. Maybe it's an automobile, or maybe it's any engineering product, because these two products will have a different life cycle. And accordingly, we will have a medium-term planning associated with that particular product. So in general, aggregate planning or medium-term planning is considered to be the planning for 1 year. So as a part of the medium-term planning, then we have an aggregate planning where we plan for the material, what will be the capacity that will be required over a period of time, maybe for the medium term, that is 1 year. So all these decisions, aggregate planning or the material planning, capacity requirement planning, all will be considered as a part of medium-term planning. And then at the third level, we have a short-term planning. So short-term planning is normally done maybe for a day, or it may be for a week, or at the max 2 weeks. So the long-term planning is converted into a medium-term planning, wherein we plan for a year on a monthly basis, and then we have a short-term planning, which, or whatever the monthly planning that we have, we try to execute it through a short-term planning. So we have a short-term planning wherein the scheduling plays a role. So scheduling is a part of short-term planning, because when we are looking at planning for a week's production, so in that case, which machines are available, which workers are available, what is the workforce size that is available, and based on all these constraints, we have to plan for how many production or what will be the schedule, maybe in the next week or maybe in the next 2 weeks. So short-term planning will involve the scheduling, and scheduling will be a part of the short-term planning process. Because if you look at the scheduling of the operations, it's a kind of a planning tool for the short-term period, as we already discussed. So it gives you an opportunity to make use of the new information, okay? Because you cannot have an information during the aggregate planning, because in aggregate planning, you make a planning for a year. So on a month-wise basis, you have the planning, but then you will not be knowing that which machines will be available during a particular month. So that we always know on a short-term basis. So whenever you have got a recent information, maybe for a week, so in that period, you can make a planning as far as the short-term planning is concerned. So it will give you, a short-term planning will give you some kind of an opportunity also in terms of, we can say, the fine-tuning with the decision due to the occurrence of the random event. For example, if any machine fails, and if that machine is under breakdown, maybe for 2 years, maybe for 2 days or 3 days. So based on that, you can tweak your production plans, we can tweak your production schedule, so that you can adjust your production plans with meeting the demand. So as a part of the scheduling, as a part of the short-term planning, you can ensure that your day-to-day production or day-to-day operations will be smoothly performed, and scheduling will be a part of the short-term planning as far as the planning process is concerned.
Sir,
So
if you
when we
kindly,
look at the scheduling aspect, that means we are looking at planning in a very short term, maybe a week or maybe 2 weeks. So the question here, or the problems that we have to address, are how do we assign the jobs to the various work centers, which job will be assigned to which machine, and within each machine or within each work center, what should be the sequence of the jobs, okay, in what sequence you will process, because whatever the priorities that you have based on the availability of jobs and based on the availability of the other resources, maybe the manpower, maybe the machines, maybe the material, you can decide the sequence in which you will process the jobs. The third point is, how do we assign other resources? Okay, so for example, the skilled workers, the material handling devices. So based on the availability of all these resources, based on the constraints that are associated with all these resources, you may take the decision. Then how do we react to a breakdown to the system? Okay, so for example, you have a schedule that is going on, and suddenly if any machine that goes in a breakdown state, okay, so in that situation, how you will reschedule the activities so that whatever is your requirement in terms of delivery of the particular product, that can be adjusted. So maybe you will have to go with an overtime production, or in some other situation you may adjust it based on an outsourcing or whatever the situation, and depends on how is the availability of the product. So all these decisions will get involved when you are looking at the short-term planning. Similarly, how do we measure the performance of the operating system? So in what way you will measure the performance, on what basis you will evaluate the performance of the operations system? It will be based on whether the flow time, or it will be based on the lateness, because if the resources are not available, and if it is affecting the schedule, so in that case, how it is going to affect the delivery? So will it result in a late delivery of the product? Will it affect the product's flow time, that we call it? That means product will spend more time in the system, because in any system where the shelf life of the product is small, for example, if it's a perishable product, it's a food production line. So in that case, if some random event it occurs, maybe it's a failure of any machine, and in that situation, if the product or the raw material is spending too much of time in the system because the machines are not available, so in that case, since it's a perishable product, its shelf life is low, so it may become an obsolete product, it may become spoiled. So all these important things that we have to evaluate as a part of the performance measure, and based on that, we can ensure the smooth activities of the different operations planning. Okay, so scheduling, many times we get we use it like scheduling and sequencing, but then these two terms are different. Okay, scheduling when we say, and sequencing when we say. So sequencing is nothing but what? It's just a rank ordering of the activities. Okay, for example, let's say if you have 3 activities, and if you want to sequence those activities, so you may either sequence it like 1, 2, 3, or 2, 3, 1, or 3, 1, 2, so on and so forth. But when we say it's a schedule, so unless we allocate the time units to those particular rank order, or the sequence of the numbers, or the sequence of the activities, it cannot become a schedule. So when a particular activity is allocated a time, that means at what time it will start and at what time it will get finished, then only it becomes a schedule. So there are a number of terms that we need to utilize, or we need to consider when we are looking at the scheduling decision. The first term, that is called the loading. So loading is nothing but it's a planning methodology by which we allocate the resources to the number of jobs in the planning horizon. For example, let's say if you have 10 jobs and if you have a week's time. So which job is allocated to which machine at what time will be a part of the loading activity. Okay, so in loading, we allocate the resources to the number of jobs during the planning horizon or the time. Scheduling will involve the rank ordering of the jobs in front of each machine. That means once you have allocated the jobs to the machine, for example, we have 3 jobs A, B, C, and suppose we decide that A and B will be assigned to machine number 1, but then in which order these 2 jobs will be processed, whether A will be processed first or B will be processed first. So that will become then a part of the scheduling process. So scheduling will involve the rank ordering of the jobs, and of course we have to allocate the time. That means at what time the job will start and at what time the job will finish. That will be based on how much is the processing time for the individual job. The third term that we call it as a routing, it's the order in which the resources available in the shops will be used. So the order that will be followed by the particular resources which are available in the shop, it will be called as a routing. Of course, sequencing, we have already discussed that it's an ordering only. That means in what sequence you are going to process the jobs when we have loaded the jobs to the particular machines, and based on that, if you have n number of jobs that are available in front of the machine, in what sequence you will process the job, so that the job will be processed based on achievement of certain performance measure, because different jobs will have a different requirement in terms of the performance measure that we call it. So sequencing will just involve the ordering of the jobs. Similarly, one more term that we call it as a dispatching, it's nothing but an administrative kind of a process. So once all the plannings have been done, it's nothing but it's an authorization to the shop floor people, so that they can process the jobs in that particular whatever the route that is to be achieved, whatever the loading that is being done, and whatever the schedule that is associated with those particular jobs are concerned. Okay, so routing becomes the first step in any production planning and the control process, and we have already discussed that it involves the path in which the work will process through the different resources in that particular organization. So as a part of routing, we decide in advance the quantity and quality of the product, which of the resources, that is the manpower, the machines, and the material will be used, the type, number, and sequence of the manufacturing operations, and the place at which that particular product will be processed. So in short, we can say it will try to answer the questions, or if we want to know that what, how much, with which, how, and where the particular product will be processed, so you can get the answers to all these questions based on the routing decisions related to the particular production process or the particular production system is concerned.
Sir, can we consider or can we learn all these term with reference of any standard sheet which is normally followed in standard company, where all these terms are reflect in any Excel sheet or any standard format, where we can understand that this is the routing, this is the sequencing, this is the aggregate planning standard format. Like this, if you share some standard format which are followed in standard company, so it will be very beneficial for us to understand this term.
I will share it. Okay. Yeah.
So basically, he's asking, sir, about some example, like if even if it is from some books, or also some example that how layout is being, how routing is this, how scheduling is this.
I got your point. I suppose all of you, many of you are from the manufacturing organization.
Yeah, but we are not doing supply chain management.
To some extent,
this is all
to some extent familiar with these terms. So because we will be using this as a part of the analytical aspect that we are going to discuss. Okay, so that's why I suppose that I should revise it. But of course, I will share it. Okay. Yeah. So if we look at the scheduling aspect, the scheduling, it becomes the last stage of the planning process. Okay, because whatever the aggregate plans that you have prepared, whatever the long-term planning that you have done, so the production process, actual production process, it will start after the production schedules have been prepared. So in operations planning, if we consider, the scheduling will become the last stage of the planning process. And after the production schedules are prepared and once the dispatching is done, the production process will start. So it will specify that when the labor, equipment and facilities are needed to produce a product or provide the service, because production schedules will give you at what particular time a particular job will be processed on what particular machine, at what time it will enter the machine, at what time it will leave the machine. So all these micro level information will be available. So based on that, you will have a requirement in terms of, or information in terms of, when the labor will be required. For example, let's say if you have a schedule for the next week, so how many labor that will be required, how much manpower will be required, and at what time, whether you may plan it on a daily basis also. Okay, on Monday we will require so much of manpower, on Tuesday. So production schedule will give you that in when you will require that particular labor and in what quantity again you will require, which equipments will be required. For example, you have a production schedule, let's say on a daily basis, maybe for a week. So if the particular product, it requires a different kind of a material handling, so in that case, you will be knowing that this type of equipment will be available, so that based on the availability of that, you may, if it is not available, you may adjust your schedule. So based on the production schedule, you will be knowing that when the labor will be required, when the equipments will be required, or when the other resources that will be needed or that will be required for the particular product or the particular process will be involved. So scheduling will give you allocation in terms of start and finish time to each particular order. So based on the sequence that you have planned, and based on at what time the product will start its operation and what time the product will finish, and based on that, at what time the order will get completed. So you will be getting the information in terms of at what time the particular order or the particular batch will be finished. That will be based on the scheduling. And of course, scheduling can bring the productivity in shop floor by providing a calendar for processing a set of jobs. Okay, because it may be any productivity, it may be in terms of the labor productivity, it may be in terms of the material productivity, or if you look at any other productivity measures. So scheduling will form the basis for all those, because as a part of scheduling, you will be knowing that at what time the particular material will be required. Okay, so based on that, you may have your inventory planning, and or otherwise you can say based on the inventory status that you have, you may adjust your schedule. So in that way, it will bring a productivity to the material management. Similarly, what kind of labor that will be required, how many workers will be required. So that information also you will get it based on the schedules. So it will also bring a productivity to the particular labor productivity. So if you look at any driver that is associated with the business, it may be a quality, it may be a quantity, it may be a cost, it may be a service, or it may be a delivery. So even service will get affected if your schedules are not correct, because if you have promised some date to the customer regarding fulfillment of the order, but there is something happen in the in the industry based on which your schedules are affected, so definitely it will have an effect on your service aspect, or it may be a kind of a delivery that you have promised to the customer, or it may be even a quantity. Because if something has happened and if your schedules are affected, definitely it will affect the quantity. That means whatever the order that you have to supply, or the time at which you will have to supply. So it will affect your service. If your schedules are affected, and if to meet the service aspect, if you have to work with an overtime, or in some situation if you have to outsource, so it may even increase the cost of manufacturing, which will affect on the profits for that particular organization. So we can see that scheduling is a very important aspect as far as any organization is concerned, and there will be a lot of effect of the scheduling decisions on the other aspects that are associated with the business or the manufacturing organization. So even supply chain will get disrupted if the schedules are not properly being managed and they are not properly being implemented.
Sir, so daily
Okay.
rescheduling is happened because several breakdowns are happened in the industry and in every department. So daily rescheduling activity, we have to
So it
perform
depends
daily
on,
rescheduling of the.
yeah, it depends on the organ. That's why we have to make a scheduling decision as a part of short term, because whatever the recent information that you have, based on that you can prepare the schedule, and that's why it is called the last stage of the production process or the planning process, because based on whatever the current information that you have, may be related with the machines, may be related with the manpower, may be related with the material availability, you can prepare a schedule, and based on that you can execute your plans. Okay, so in situation where a particular machine is not available because of certain failure, you may have to reschedule it, or in some situation, if that particular machine is in maintenance, so maybe you can think of making an overtime once the machine is ready, or you may have to go with one more shift if it is not available in the regular time. So you may have to go for an overproduction, or you may go with the second shift, or maybe with the third shift. So all these decisions will be based and based on that, you may revise your schedules, and accordingly you may achieve the required quantity or the delivery that is associated with the product. Okay, so the classical tool which is very popularly used over a period of times and for many years is a kind of a Gantt chart. Okay, so a Gantt chart is nothing but it's a bar chart which is very popularly used as a scheduling technique or a scheduling tool. And it's a very old technique, but still in many situations we use the Gantt chart for the different planning and scheduling. And it can be used as a load chart, it can be used as a kind of a planning process. So we can see that Gantt chart is very popularly used. It's a kind of a bar chart. So the bar in each row, it identifies the corresponding task. Okay, so if it is a kind of a planning process, so you can see that the bar particularly that you have utilized, it will show the time at which the particular activity will start, and the time at which the particular activity can be finished. And the bar length, it particularly represents the duration of the task. And you can use the Gantt chart in many ways. Based on that, you may have a kind of a status or a review, so that a particular if you take a review at a particular time, you will get to know the current status of the particular planning process, and maybe based on that you can either replan the activities, or you may take some kind of some corrective action. Based on that, you can try to fulfill whatever the backlog that is associated with the activities. So it's used as a load chart, it's used as even the planning for the planning processes. So there are many ways in which you can represent it as a planning purpose. For example, here you can see this Gantt chart is used as a load chart. Okay, so for example, we have these 4 mechanics, and if we want to know that during the entire day, which operator is working on which particular job. So for this particular purpose, we can use the Gantt chart as a load chart. For example, this particular mechanic Bob, he is working for 3 hours for job A, then he is working for 1 hour for job G, and maybe for next 4 hours he will be working on job I. So in this way, the Gantt chart can be used as a kind of a load chart.
So this will be prepared in Excel or any
you can
specific
prepare
software?
it in Excel, or even there are techniques or softwares available, but you can very easily prepare in an Excel sheet. Okay, I will show you how we prepare it in an Excel sheet. Okay. It just, you have to allocate that particular time slot, and then you have to represent it with a kind of a bar chart that is considered as a part of Gantt chart. So the point here is that you can represent the Gantt chart as a load chart, wherein you can represent the loading of the different resources. For example, it's here shown the loading of the mechanic. Similarly, you can show the loading of the machines also. For example, machine A, on machine A, which job will be performed at what time. So we can represent, or you can use the Gantt chart as a loading chart for the machine and job configuration. Similarly, you can use the Gantt chart as a loading chart for the machine and the operator kind of loading chart. Similarly, you can use the Gantt chart as a progress chart. So for example, you have a set of activities that needs to be performed, okay? And for each activity, you have a schedule. For example, in any construction work, this Gantt chart is very popularly used for the planning purpose. So the first activity, let's say it's complete the design specification, and let's say you have planned it for the 2 months, January and February. Okay, similarly, you have a set of activities, and based on that, you want to prepare the schedule. So you can utilize the Gantt chart. So let's say you have a 1 year activities, and in that 1 year, you have to perform different activities, and each activity will have a different kind of the schedule or the different times that have been allocated. So you can use it as a progress chart, and based on the planning, then at any particular time, you can look at what is the current status. So for example, here, you can see here that during this particular month of May, what is the current status. So you can see that if you can look at this activity is finished, this activity is finished, this activity is finished, and let's say this activity is not yet finished. It just started up to this much. That means you can see that the planning was that this activity has to be completed, but then this activity is pending. So you may look at either replanning it, or you may look at arranging some resources, some corrective action, so that the requirement of this activity can be fulfilled. Similarly, you will get to know that this activity is not yet started. So in this way, you can use the Gantt chart as a kind of progress chart in planning process. Similarly, you can use it in terms of the planning for the jobs. For example, here you can see that the particular job is scheduled, job number 3 is scheduled on machine 1, and it's taking 2, it will be finished at this particular time 2. Then the next job on machine 1 will be job 1, it will be finished at 6. So let's say at the end of this particular time, if you want to take a review, so you can see the progress of the job, okay? So you can see that, or you can evaluate whether job 1 is loaded or not. So if the job 1 is not loaded, in that case, you can see that if some problem has occurred and maybe based on that, job 3 is delayed. So you may look at that particular reason, and based on that, you may take some corrective action. So this Gantt chart can be used as a progress chart. So in many situations, you can see that Gantt chart is, even though it's a kind of an old technique, but still we can very well utilize for effective planning purpose. So it's a simple tool. It gives you a good visualization, and you can compare the task durations, that which activity is taking more time. For example, here you can see that job 3 on machine 1 is taking less time as compared to, or it is requiring less time as compared to machine 2. So if you have a set of large amount of data that is available, based on this kind of a Gantt chart, you can visualize that the task durations, and it's very popular tool, and it's a very good tool. That means in terms of the scheduling of the resources. Okay, so you may use it for any planning purpose. For example, this is used in some kind of a planning process related to the academic activities. So let's say it's a kind of an academic activity which is related to completion of, let's say, a coursework. It may be a kind of a PhD work even. So in that case, what is the planning over the next 3 years, and at what time the student is supposed to complete which activity? So this may be a kind of a representation using the Gantt chart. Okay, so when it comes to the scheduling of the jobs, let's say we have a number of jobs and we have a number of machines. So in simple term, we just want to decide that based on the number of jobs that are available or based on the number of machines that are available, which job needs to be allocated to which machine. That means a kind of assignment situation wherein, let's say you have 4 jobs available and 4 machines or 4 operators that are available. Okay. And then each operator will take a certain amount of time, or it may be a certain cost that is associated with the particular job. For example, let's say the worker A here, if he is performing job 1, he will take 8 minutes. If worker B is performing on job 1, he will take 6 minutes, so on and so forth. So in such situation, wherein we are looking at a decision in terms of allocating the jobs maybe to the workers or allocating jobs maybe to the machine. So it's a kind of an assignment situation. So in that situation, we may use an assignment model to allocate the jobs to the particular machines, or in this case, the jobs to the particular worker. So here it is representing the cost that is associated for each worker if he is performing on that particular job. So because depending on the requirement of the job, the particular worker will be paid, or the particular worker will charge his wages for that particular job is concerned. So there is one popular method that is called the Hungarian method. You might have done it maybe in your module 1 using the solver. Okay, so you can do it in Excel also using the solver, but the scientific method that is available, which is called a Hungarian method, if we are coming across such situation where we are looking at allocating a number of jobs to the elongation machine. So in this case, it is just an assignment that which job will be assigned to which machine. So it's a kind of a heuristic approach. So this researcher or the scientist Hungarian, he looked at such kind of a situation where we need to assign the jobs maybe to the machine, or maybe the operator to the machines, or maybe operator to the jobs, or in other situation, for example, if in case of an airlines industry, if the particular pilot has to be assigned to the particular aircraft. So in many situations, we need to schedule the particular allocation of the combination of 2 activities. For example, in this case, it's a job with the worker. So the algorithm, or this is a kind of an heuristic method, or this is a kind of an algorithm. So it says that you have to perform 2 operations. One we call it as a row operation, the other one is the column operation. And in this case, you have to first subtract the smallest element in each row from each number in that row. Okay. And next you have to perform the column operation, and you have to subtract the smallest number in each column from each number in that particular column. And whatever the metrics that then results based on these 2 operations, row operation and the column operation, you have to decide the minimum number of lines. So if the minimum number of lines by which you can cover all the zeros in that particular matrix, if it is equal to the number of rows, in that case, you can make an assignment. If it is not, then the next step of the algorithm, it has to be applied. In that case, whatever the unassigned numbers in that, those have to be subtracted from the other numbers, and what that number has to be added to the particular intersection of lines. So these algorithm steps are given here. So maybe based on that, we will look at how we can implement these particular steps from this example. Okay. So let's say we have these particular so have you done it in The other module that is related with the analytics tool?
No, sir.
No, sir.
Linear
No, sir.
programming method we did there, but Hungarian method we did not do.
No, not Hungarian. The assignment problem.
Yes, we did. In operations management.
Assignment problem you studied,
Yes.
using solver.
Yes.
Okay, so that basically it works on the simplex LP, that is the simplex algorithm. Okay, but of course simplex is having a kind of a limitation, or the solver is having a kind of a limitation in terms of the number of variables. So in that particular situation, whenever the number of variable it increases, or whatever the softwares that will be working on the assignment problem, they will basically working on the Hungarian method, because this is a classical algorithm which is available for this particular assignment problem. Okay, so we'll see that how we can, and of course as a part of scheduling, we can use this Hungarian method for deciding the assignment of the jobs, maybe to the machine, or maybe the machine to the operator, or a situation wherein we are just looking at assignment of the two elements which are associated in that particular problem. So as per this method, what it says that you have to find the
lowest in row.
So as a part of this method, what we have to do, we have to find the lowest of each row, and we have to subtract it from each element in that particular row. For example, here the lowest element in first row is 2. So we will have to so the lowest element here is 2. So we will subtract this element from each number in that particular row. So in this row, the lowest is 6. In this row, the lowest is 3. And in this row, the lowest is 5. So this will get to 0, 1, 5, and 4. Okay, so based on that, you have to perform the column operation. Now, when you will perform the column operation, you have to subtract each element, the smallest element of that column from each element in that particular column here. So for example, in first column, the lowest element is 0. So you will subtract from each element. Similarly, in column B, the smallest is 1. So that you will subtract from each element. Then in column C, you have 0.
Sir,
yes.
please repeat, sir. I haven't seen 0 in column C.
So in column C.
Oh, okay, sir. You are matching with row option. Okay, sir. Thank you.
Yeah. You have to either first have to do the row operation and then column operations. Okay. And in column D, you have the smallest element 2. So it's 0, 2, 1, and 2. Okay. So based on this, you have to look at that. Based on the row and column operation, now you have to cover these 0 with the minimum number of lines. Okay, so for example, if I want to cover this, so let's say this is one line, this is second line, and this is the third line. Okay. So how many lines we have used here? Number of lines by which the zeros are covered is equal to 3, and the number of rows here are 4. Okay, so number of lines is not equal to number of rows. Okay, because this is 3 and this is 4, so this is not equal to this. So what you have to do, you have to perform some So what you have to do here now, whatever the unassigned elements are, so these are the unassigned elements. The elements which are not being covered by the lines. Okay. So out of these, you have to find the smallest value. So the smallest value here is 1. Okay. So these smallest value you have to subtract from these elements which are unassigned. As a part of this method, if the number of covered lines which are covering the zeros is not equal to the number of rows, you cannot make an assignment. Okay, because here the lines are 3 and you require 4. So you have to allocate here 4 jobs to 4 operators. So to make an assignment, you have to get number of lines equal to the number of rows. So since it is not equal to number of lines with the number of rows, you have to find the elements which are not covered and you have to select the smallest one. So this is the smallest. And this smallest number you have to add to these elements. Okay. And along with this, you have to add it to the intersection point of the lines. For example, this is what is the intersection point, and this is what is the intersection point of the lines. So wherever the lines are intersecting, at that particular point you have to add. So at this particular point you have to add, and from all these elements you have to subtract. Okay. So with this, when you will perform, so what you have to do here, from these elements you have to subtract, and to these elements where the lines are intersecting you have to add it. So for example, here it's an intersection, so the smallest element is 1, so you'll have to add it there. So it will become 6 plus 1, 7. Since the other elements which are on the line, they will have to be as it is. Similarly, again, this is an intersection point. So it will become 1, 0, 5 and 2. And here it's 0. Here it's 1. So you have to subtract. So it will become 0. This will become 3. This will become 0. And now here 0. Again, this will be 3. This will be 6. And this will become 1. Okay. Now with this, again, you will check whether it is covering the number, how you can cover these number of lines, the zeros with the number of lines. So let's say this is one line. Okay. This is another line. This is one more line. So how many lines here? Now the zeros are covered with 4 lines and we have 4 such rows. So in that case, now we can make an assignment. So let's do it, the assignment now. So for making an assignment, So now with this matrix, we'll make an assignment.
So why the fourth one is lined, sir?
Okay, so this is what is the matrix, and to this matrix we will make an assignment now. Yes.
So why the fourth one was lined 0, 3, 6, 1?
See, once you have done these operations, row and column operations, you have to check with the number of lines by which you can cover the zeros in this particular matrix. Okay. So you have to get, or you have to cover these zeros with the minimum number of lines. So since if by any combination, if you try, you will see that there are 3 lines by which you can cover the zeros. Okay, straight lines.
Okay.
Horizontal and vertical only. If this is equal to the number of rows, because we have to make here 4 assignments. So if you are able to cover these zeros with the number of lines which are equal to the number of rows, in that case you can make an assignment. But since here the number of lines is less than the number of rows, you will have to go to the next step. Okay, so you will go to the next step wherein whatever the elements which
Sir, in the green matrix, there are 1, 2, 3, sir, 4 lines. Five lines are, sir.
No, there are 4 lines by which you can cover the zeros.
Okay, sir. Thank you, sir.
This is 1 line. This is 2nd line. This is 3rd line, and this is 4th line. Okay. So based on the row and column operation, if the number of lines is less than the number of rows, in
sir,
that
here,
case,
sir, here we have to take the minimum number of the line which can cover the zero.
Yes.
Okay, sir. Thank you.
So here you can see that since the number of lines are less than the number of rows, what you have to do, the next step, that whatever the unassigned elements are here, which are not covered by these lines. So this is what is marked in the green color here. Okay. Out of these, you have to find the smallest number. And this smallest number you have to subtract from these particular numbers which are not covered in the lines. So you have to subtract it, and wherever there is an intersection of the lines, for example, at this particular point and at this particular point, there is an intersection. So to these intersection points, you have to add that number, which is the smallest here is 1. With this, the next matrix you have to compile. Okay, so this is what is the next matrix. For example, here it was 6. So since it's an intersection, we have to add it. So it will become 7. Similarly, here also there is an intersection. So we'll have to add it. It will become 1. And from this, we have to subtract it. And now to this transform matrix, we have to again look at how many lines by which we can cover the zeros. So in this case, we can see that if we cover the zeros, it is equal to 4 lines. And once you get the number of lines equal to the number of rows, which will cover all the zeros for the row and column operation, in that case, you can make an assignment. So now what you can do, to make an assignment, you have to find the row where there is only single zero. So for example, in row number 2, there is only single zero. So you have to make an assignment to that, and you have to cross all the zeros in that particular column. Okay. So since assignment is made at this point, because it's having a single zero, we have crossed all the zeros in that particular column. You have to go to the next row. Again, there are 2 zeros. We will not select it. You have to go to the next row. Here there is only single zero. So we will make an assignment here. And then you have to cross all the zeros in that particular column. Okay. Again, you have to go in a row wise fashion. We cannot do it here. we cannot do it here. There is a single zero, so we will make an assignment here. We have to cross all the zeros in that particular column, and then whichever zero is remaining, so this is what is the zero that is remaining. So what is the assignment now here? Job 1 will be assigned to operator C, job 2 will be assigned to operator B, job 3 will be assigned to operator D, and job 4 will be assigned to operator number A. And if you look at the cost will get to whatever the cost that is involved. So in this way, if you look at the cost, it is 2765. So the cost is 2, this is 7, this is 6, and this is 5. So this will get to 20. So for this kind of a situation, you can see that this is the minimum cost in which you can make an assignment. So if you have number of jobs, and if you have number of machines, or if you have number of jobs, and if you have number of operators, so in that situation, when you just want to make an assignment, you can use this particular method, the Hungarian method, by which you can get the solution. Okay, but of course, for a large size problem, you will need some kind of a computing tool, and even with the solver and using the Excel, you can perform or you can solve the assignment, the problem. Okay. So I hope you have done it with the solver. Okay. Okay, so this was about these scheduling techniques. That means a Gantt chart is used just to prepare a load chart kind of a thing, or it may be a kind of a progress chart that you can use as a part of the planning and scheduling. Similarly, we can use the assignment method, wherein we are just looking at a situation wherein we have a number of jobs and we have a number of machines, and based on that, if we have a requirement in terms of which job needs to be assigned to which machine, in that particular situation, we may solve it as a kind of an assignment problem, maybe using the solver, or maybe using such technique like an Hungarian method, which will give you a kind of assignment of the particular jobs to the particular machines, and based on that, you may achieve that particular assignment at a minimum cost, or whatever the other performance measure. It may be in terms of the minimum time. For example, in this example, we have considered the cost, but it may be a processing time even. Okay, so in that case, whatever the assignment that you will prepare based on the assignment model, it will give you the assignment to those jobs, to those machines, that will be completed within that minimum time. Yes.
Sir, can you please show the question? What was the question?
Question?
Yes, sir.
This one?
Yes, sir. Sir, here so 8624, what is the 8624?
These represents maybe the cost.
Okay, sir.
Okay, for example, operator A, if it is working on job 1, it will involve a cost of 8.
Okay,
operator sir. B, if he is working on job 1, it will be cost of 6. Okay, so it may be a cost, or it may be even a time also. For example, if worker A, he is not so skilled, so if he is working for job 1, it will take 8 minutes. Similarly, if job worker B, if he is working on job 1, he is to some extent more skilled, he will take 6 minutes. Okay.
Okay, sir.
And in such situation, if you are concerned with which job, then you will allocate to which machine, so that you want to complete all the jobs in minimum time or minimum cost. So this kind of methods will give you the assignment of the jobs to the worker, or maybe to the machine. Okay, so whenever we are looking at the scheduling problems, we have so many aspects that we have to look at. That means the number of jobs, the number of machines, and we have a different configuration of the manufacturing systems, which we have already discussed. It may be a flow shop which is used for the mass production or mass manufacturing. For example, an assembly line that we have considered. So an assembly line is nothing but it's a flow shop kind of a manufacturing situation. It may be a job shop wherein the job moves in a very zigzag way, because each job will have a different processing requirement. So it may be a job shop kind of a situation, or it may be a cellular manufacturing system. Of course, there will be a priorities for the jobs. It may be the first come first serve, or the shortest processing time, or it may be a longest processing time, or it may be the earliest due date for the job. It may be a kind of a random ordering. It may be a longest schedule. So whatever the priorities that exist for that particular job, it may be based on the performance measure. For example, the performance measure can be the due date base. So whatever schedule that you are preparing, it should meet the particular due date, because each order is promised certain date on which the order will be delivered. So the performance measure may be a due date kind of a performance measure, or it may be a lateness. For example, if any job is late and you want to prepare a schedule so that it will have a minimum lateness for the job, because if each job is getting late based on the schedule, then it may not achieve your delivery aspect, or it may not achieve your service aspect for that particular order is concerned. Or it may be a tardiness. Tardiness is a situation wherein there is some kind of a penalty that is associated. Okay, so if the job is late and if there is some penalty in terms of the cost that is concerned, so in that case, this aspect will be important. For example, let's say in case of a construction of a highway project. So if that particular project, if it is completed on time, that is okay, or there may be some incentive. But if the project is get delayed, there is a penalty that is associated. Okay, so whatever the scheduling of the activities which are involved in that particular project, if the scheduling is not proper, so in that case, if any late, if that project gets late, so in that case, that particular project may have a penalty in terms of the cost that has to be given to the client. Similarly, in manufacturing also, there may be a situation wherein there may be a penalty that may be associated with the lateness of the job. Okay, for example, let's say you have any customer order, and if that particular order is to be fulfilled on time, by which you have given some, or you have promised certain date for that particular order, and let's say you have planned for some kind of a normal mode of transport by which you will deliver that product. But let's say the product is late now, and in that situation, you want to deliver the product to that particular customer on time. So in that case, you will have to go for some faster mode of the delivery. So let's say for normal mode, you have either selected by the road or maybe by the rail. But in a situation where you want to use a faster mode because of the schedule, your production order is late now, but you want to give that particular order to the customer on time. So in that situation, let's say you have used some other mode or the faster mode, which is by air. But of course, the charges that needs to be incurred when you are transporting the product by road and when the product is to be transported by air, it will be very huge. So in that case, any lateness that will get associated because of the schedules, that will result in penalty. Okay, so in that case where there is some kind of a penalty or is associated, in that case, this particular performance measure that is used, which we call it as the tardiness. Similarly, it may be a completion based. That means at what time the job will get completed. So in a situation where there is certain shelf life of the product, okay, and if the product is completed beyond its shelf life, so in that case, the product will become obsolete or it will be spoiled. So in that situation, scheduling plays a very important role. And in that case, whatever schedule you will prepare, it has to be based on the completion time for that particular job. If that job is completed before the shelf life, that is useful. If it is completed after the shelf life, that product will become an obsolete product. It may be a flow time, it may be a make span, or it may be an inventory or cost base. So there are so many aspects which we have to look at when we are looking at any scheduling problem that is associated with the number of jobs or number of activities that we are looking at. So based on these particular performance measure, we may have different objectives in the scheduling. For example, the first objective, it may be to meet the customer due dates. Okay. So you have certain orders and you have given a date to each customer. Okay. Let's say you have 10 different orders from 10 different customers, and each customer is being given a different due date. That means at what date the order will be delivered to that customer. Okay. Now the question here is, in what will be the schedule for this order, or in what sequence you will process the order, so that whatever the date that is promised to the customer, you will be able to meet those particular dates. So in that case, the objective for the scheduling problem will be then meet the customer due date. It may be related with the job lateness. Okay. That means in a situation where the job has to be delivered on time. So if any job is late, it will affect the due date or the order status. So the objective can be in terms of minimizing the job lateness associated with each job. It may be based on the completion time. That means for a particular order or for a particular job, we would like to minimize the completion time, so that, because based on what sequence you are processing the job will be completed. Okay, because whatever time that particular job will take. For example, if the processing time for a job is 5 minutes, so at what time it enters and at what time it will finish. So if it entered at the first minute, it will be finished by 6th minute. But based on the schedule, if it enters at 10 minutes, it will be finished by 16th minute. So based on that, we may have an objective in terms of what will be the completion time, and based on that, we will have an objective that we want to minimize the completion time for the jobs associated with that particular schedule. Similarly, it may be minimizing the time that the job spent in the system, because when you have a schedule for all the jobs will be lying as a raw material. Okay. And then based on the processing, the job may be lying as a work in process. So the work in process status of the job will depend on what is the schedule. So in that situation, the objective may be based on minimizing the time that the job spent in the system. It may be a requirement in terms of minimizing the overtime, because whatever the schedule for the job you have, and if that schedule is not able to meet the promised date, so in that case, the corrective measure can be an overtime. So in that case, the objective for the scheduling problem may be in terms of minimizing the overtime that is associated with that particular jobs and that particular order which you are supposed to process. Similarly, the other objective can be maximizing the machine or the labor utilization. So whatever the labor or the machine that is available, it should not remain idle. Okay. So if your schedule is such that it is causing too much of idleness for the machine or for the labor, because if the job is not available to the job operator, he will remain idle. Or if the earlier stage has not yet completed the job, the next stage machine and the next stage operator will remain idle. And all this will happen based on what is the schedule, at what time the particular job enters on that machine, and at what time a particular job leaves at that particular machine. So it may be in terms of minimizing the idle time, or it may be in terms of minimizing the work in process inventory. So when you are looking at scheduling problem, you can see that there are so many objectives that need to be fulfilled. And if any of these objectives are not met, it will have an effect on either the quantity aspect of the manufacturing organization, or it may be on the delivery aspect of that particular organization or service, which we consider as the drivers for any business, that is quality, quantity, cost, delivery, and service. So to achieve most of these objectives, scheduling is one of the important element of the operations management or the manufacturing systems management is concerned. And when we are looking at scheduling problem, we'll have to look at these particular objectives that will be that will serve as a kind of performance measure, because we can see that whenever we are looking at the performance measure, the performance measure for the schedule, it can be due date, it can be lateness, it can be tardiness, it can be flow time, make spine, all these will be involved. Okay, so I hope all these are clear. If anything is not clear, you can ask, because these are important aspects as far as any scheduling problem is concerned. So whatever schedule that you are preparing, it should meet certain of objectives, and whatever schedule you will prepare, it should be based on achieving that particular performance measure. So whatever schedule you want to prepare, it should serve or it should fulfill either of these objectives, which are important from the organization point of view, because it will have an effect in terms of these performance measures: quality, quantity, cost, delivery, and service. These are considered to be the main drivers for any manufacturing or business organization. What is the time now? Okay, so there are different configurations, and depending on what is the configuration for the particular shop or the manufacturing shop floor, each shop floor configuration will have a different kind of a scheduling. Okay, for example, if we have an assembly line manufacturing which is utilized for mass manufacturing, the scheduling algorithm will be different. If it is a kind of a job shop problem, the scheduling problem or the scheduling algorithm will be different. Even if it is a single machine wherein we are looking at scheduling the jobs, because as a part of the loading, we have allocated the jobs to the machine. And when we look at the schedule for the particular machine, even in single machine case also, it will be a different kind of scheduling problem or scheduling algorithm that needs to be implemented. So in case of a flow shop where the resources are organized in a kind of a sequence, because in flow shop or in assembly line manufacturing, the job has to be processed in a particular sequence. For example, in a car assembly, the components are to be assembled at different workstations. We have already looked at the assembly line balancing problem. But in that situation, if you have a number of orders that need to be processed, for example, let's say for a Maruti car, there are various variants of the car model, and each car model has a different requirement in terms of a quantity. Now, for that particular organization, the problem here is that which order or in what sequence those particular models have to be assembled on that particular line. So there are many variants of the shop flow problem even. So in a simple or pure shop flow problem in which all the job will visit the machine in the same order, okay? Because in case of a flow shop manufacturing, the processing sequence on each job is fixed, okay? And based on that, we try to fulfill the requirements of the processing in terms of assembling the car, or maybe a kind of processing that is required on that particular job. So a flow shop scheduling will have a different kind of a scheduling requirement. Similarly, in case of a job shop, okay? So in job shop, each job will be having a different requirement in terms of the machine configuration. For example, let's say job 1 will require a machine in terms of 14256 here. Similarly, job 2 will require requirements in terms of machine number 321467. So in job shop, you will see that it's a very complex situation. And in that particular, even the complexity of the scheduling problem, it increases a lot. Okay, so you will find that job shop scheduling problem is a very complex problem, and a lot of research is going on to even achieve the solution to the job shop scheduling problems. Okay, so we will take a break for 10 minutes and then we will resume the session. Okay, so as a part of scheduling, there are many priority rules which are used. It may be a first come, first serve, or it may be a last come, first serve. So whatever job that is received first. So it's a kind of a queue formation for the jobs. And based on the arrival of the jobs, you may process the job. That means whichever job is arrived first, you will process that job first. Whichever job is arrived later, you may process that job later. Or it may be a kind of a last come, first serve. So it's a kind of a situation wherein it's whatever the job that has come last, because if it is a pool of jobs that is lying, so maybe you have a priority that whatever the job which is received recently, that you will process first. It may be based on the due date criteria. So whichever job is having the earliest due date, those jobs need to be finished first. And whichever job they are having a longer due date, that jobs may be processed later. So you may have a scheduling policy based on the due date criteria. It may be based on the processing time. So whichever jobs are having the shortest processing time, you will process those jobs first. So it may be either a shortest processing time, or it may be a longest processing time, or you may have a some kind of a critical ratio that you can decide. So it is nothing but critical ratio is nothing but how much work is remaining to time that is remaining. Okay, so based on that critical ratio, whichever job is having or which is more critical in terms of the critical ratio, those you can process first. Or it may be based on the slack, it may be based on the customer priority, it may be based on the setup. So there are so many priority rules that we may consider depending on what product and what other aspects that are involved. And depending on the performance measure, the required that we have to fulfill, whichever priority rule will try to achieve that particular performance measure, you can utilize these rules to prepare the schedule for the jobs. Okay, so we will look at few of these performance measures by which we can we can prepare the schedules as a part of the priority rule. It may be the shortest processing time. For example, whichever job is having the shortest processing time, that job has to be selected first. And based on the processing times, you may prepare the schedule for the jobs. Similarly, it may be based on the longest processing time. So whichever job is having longest processing time, that means whichever job is taking more time, that job you can select as the first job, and based on that, you may prepare the schedule. It may be based on the earliest due date criteria. So whichever job is having the earliest due date, for example, let's say you have 4 jobs and each job is having a due date, and in that particular dates which you have promised to the customer, whichever is the earliest one, you may process the jobs based on that due date criteria. Or it may be based on the critical ratio. So it's nothing but whatever is the remaining time that you have and whatever is the remaining work that you have. So due date minus the current date divided by the remaining processing time. So based on what is the due date that is promised to the customer and what is the current date, and based on that we may estimate the critical ratio, and based on that we may prepare the schedule for the jobs. It may be on a first come first serve, or it may be a kind of a random situation. But of course, each schedule will result in achievement of the particular performance measure, and based on what performance measure criteria that you want to achieve, based on the objective that you want to fulfill, you may adopt the particular scheduling rule. For example, here we can say that there are 4 jobs, and these are the processing time for these 4 jobs. This is the order of their arrival. Okay, and this is the due date. That means job 1 is to be given by, let's say, 23rd time unit, job 2 is on 24th, job 3 is on 30th, and job 4 is on 20th. So based on the different rules that we have considered, for example, if you want to apply the shortest processing time, So the shortest processing time, it can be, if you look at the processing times of the job, so the shortest processing time sequence will become 2, which is the having the shortest processing time here. Then it will be 4, it will be 1, and it will be 3. Similarly, you may have it based on the longest processing time. So the longest processing time here is for job number 3. So it will be 3, then 1, then 4, then 2. If it is on the due date criteria, whatever the due date is earlier, for example, in this case, the earliest due date is for job number 4, which is 20. So in that case, the schedule will become 4, 1, 2, and 3. If it is a critical ratio, so if you estimate the critical ratio, so based on that, you may have a sequence that is 3, 4, 1, 2. So the critical ratio is smallest for job number 3, and that job has to be processed first because it's quite critical. If it is a first come first serve, then it will be processed in the order in which they arrive. That is, in this case, the jobs have arrived in the sequence of 1, 2, 3, 4. So you will process in that sequence. And if it is a random, maybe based on some random number generation, you may assign the jobs. For example, if whatever random numbers you have generated, and based on that, so let's say these are the 4 random numbers which you have generated, and based on that, you may decide the sequence for the job. But of course, whatever sequence that you have decided, it should meet the required performance measure that we have looked at.
Sir,
How the random number?
sir, how random number is decided?
Either you may use the random table, or maybe in Excel you can generate the random number. So in Excel, you can see that we have a function that is called rand. Okay. So for all jobs, you may have a random, but of course, random assignment of job is not advised, because it will not achieve the performance measure. Because in that situation, it may result in a worst kind of the performance measure for that particular job. Okay. So random assignment of the job is not advised, or it should not be utilized. You may use certain performance measures, the priority rules that we have discussed, or so all these, because definitely they will result in some good schedule or good processing sequence for the job. And random, it's a random. So in that particular situation, it may even result in a worse schedule, which will have a very bad performance in terms of the objective that is concerned with that particular order or that processing of the jobs. Okay. So you may use the priority rules, or you may use some performance criteria. For example, we have looked at different performance criteria. The first performance criteria is called the flow time. Okay, so flow time is nothing but is the time that the job spends in the system. Okay, for example, if the job is relieved at, let's say, the time R, and if the completion time of the job is C, so what will be the flow time? The point at which the job is released and the point at which the job is completed. So that is based on the sequence, because whichever job is first in the sequence, that will be completed first, and it will leave the system earlier as compared to the next job. And whichever job is last in the sequence, for example, if you consider, let's say, this sequence 2, 1, 3, 4. So the job 2 is first in the sequence. So it will spend, its completion time will be earlier as compared to the other jobs. So that job will be completed first, and its flow time will be smaller. So depending on each sequence, for example, 1, 2, 3, 4. So in that particular case, the flow time will be different. If it is 3, 1, 4, 2, in that particular case, the flow time will be different. And the objective may be that you want to minimize the flow time for the particular sequence. So you have to select that sequence which will result in the minimum flow time for the job. Okay. And this is particularly important when the product, they will have certain shelf life, because each job, depending on the shelf life, if that job completed after its shelf life is over, for example, in the pharmaceutical industry, or maybe in the food processing industries, if you have a processing of the job, and if the raw material is having certain shelf life, and if the job is processed based on the sequence and the time by which the job will be completed, that raw material will be obsolete or it will be spoiled. So from that point of view, flow time performance measure is important. And in that situation, the objective or the performance measure will be to minimize the flow time for the jobs. So the flow time we calculate based on at what time the job is released and at what time the job is completed. Similarly, it may be based on
what is the release time, sir?
Release time means at what time the job is available. Okay, so normally if all the jobs are available at the beginning of the schedule, in that case, release time for the job is 0.
Yeah.
Okay, but if suppose the job have been added to the particular pool, so you will have, or you may have, a different release time for the job. Okay. So normally the jobs are available before the schedule is to be prepared, and maybe based on that we assume that release time for the job is 0. But there may be a situation in which job will get added to the particular job pool. So in that case, you may have a different release time for the job.
So it's a
And
probable
accordingly,
start time of the job.
yes. As far as schedule is concerned, it's not
include the setup time also.
If you consider the scheduling context, it will not be a start time. Okay, start time for each job will be different, and that will be based on in what sequence the jobs are processed.
Okay.
Because in this particular sequence, the start time of job 1 will depend on at what time job 2 is completed.
Okay. That's
But
why
in
I
this
told
particular
probable start time, because it may start at 0, but it may not. Also, it may not start at 0.
No, release time is not the start time for the job. Release time is the time at which the job is available for scheduling. So normally we consider release time for jobs to be 0, because let's say you have 10 jobs which are available, and now you have to prepare the schedule for these 10 jobs. Okay, so in that situation, whatever the flow time, that will be based on what is the schedule for the job. For example, in this case, job 2 will be completed earlier. Okay, in this particular case, job 2 will be completed later. In this case, the job 2 is performed at the last. So the flow time for the job will be different in each sequence. So in that particular case, your objective will be to minimize the flow time for the job so that it should meet the required purpose for the scheduling. So in that way, you will measure the performance of the sequence or the schedule based on the flow time criteria.
Understood, sir. Yes, thank you.
Yeah, it may be a make span. So make span is nothing but it's the time taken to complete all the jobs. So let's say you have 10 jobs. Okay, you have 10 jobs, and these 10 jobs have to be processed, these 3 machines. So in that case, the time at which the last job will leave the system. So let's say here instead of 10, so let's say the sequence is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say you are processing the job in this sequence, 1 to 10. So make span, what will be the make span? makespan will be the time at which this last job, that is the 10th job, will leave the system. So that time is called the makespan. Okay, so makespan is nothing but it's the time taken to complete all jobs released into the shop for processing. The performance measure may be based on the lateness criteria. So how do we define the lateness? Is nothing but it is the difference between the completion time and due date for the job. For example, let's say the due date for the job is 20 and the job is completed by 15. Okay, so what will be the lateness in this case? So let's say this is the completion time and this is the due date. So in this case, the lateness will be equal to 15 minus 20. That means minus 5. So in this case, the job is late because no.
It's completed early, sir.
It's completed early. Okay. So it's minus 5. And in a situation where if the job is, so in manufacturing or in scheduling terminology, we have two kinds of lateness. It may be earliness or it may be a lateness. Okay. Even the job can be completed earlier. And in terms of the penalty also, we can have an earliness penalty also. Because if your jobs are completed early, you will be having an inventory holding cost associated with that particular job. Okay. So the lateness is measured in terms of the completion time minus the due date for the job. Okay. Similarly, there is another performance measure that we call it as a tardiness. So in a situation where there is a lateness penalty. Okay. So in that case, whatever the jobs which are late, those jobs will involve a penalty. Earliness, if the job is completed earlier, that will not have any impact or that will not have any penalty. So in that case, tardiness is measured in terms of maximum value of 0 or the lateness. So for example, in this case, let's say one job, we have two jobs. So one job is for job 1, the completion time is 15 and the due date is 20. And for job 2, the completion time is, let's say, 22 and due date is 15. So if you look at the lateness of these two jobs, for first job, what will be the lateness? 15 minus 20, it is completed earlier. So this is minus 5. And for second job, it is
7.
It's completed
7
at 22 and its due date is. So this is what is the late job. So in this case, the tardiness will be measured as maximum of 0 or lateness. So in this case, since it's a negative, so we will take it as 0 and 7. So the tardiness will be 7 only. So whichever job is having a lateness, that particular job will involve the penalty. Is it clear?
Yes, sir.
So if the job is completed earlier, it will not be a tardiness. It will not be a tardy job. If the job is completed late, that means beyond its due date, in that case only you will incur, or that job will be a tardy job. And in that particular situation, if there is a penalty that is associated with the job, the penalty will be imposed for that particular job. So in a situation, we may have a performance measure that we want to minimize the number of tardy jobs, because those jobs will be involving some kind of a penalty. And in that particular case, the job will be having a penalty. Is it clear, the performance measure of tardiness?
Yes, sir. Yes.
Okay, so in this case, we may be interested, or we may be looking at identifying how many jobs will be tardy jobs. That means those are going late. So let's say you have 10 jobs to be processed, and based on the schedule, you will be interested that how many jobs will become tardy job. So in that particular situation, if the penalty cost is very high, your objective may be to minimize the penalty cost, that is the tardiness penalty, or minimizing the number of tardy jobs. Okay, because the sequence, depending on the performance measure, it will have, each sequence will result in a different tardiness, or it will result in a different number of tardy jobs. So your objective in that case will be to minimize the number of tardy jobs, or to minimize the tardiness associated with that particular sequence. Okay, so we look at first the situation where we can implement all these performance measure for a single machine scheduling kind of a situation. Because when we have a number of jobs to be processed, so you will see that even in case of a single machine scheduling problem, when we are looking at achieving these performance measure, and based on that, if you want to make a schedule, to what extent it get complex, so that when it's a multiple machine situation, the complexity of the scheduling problem will be very high. Okay, so are these performance measure clear to all, or because now onwards we'll be working with these performance measures only? Because whatever technique that we will use, we will utilize these measures to evaluate the performance of that particular schedule. Okay, so let's say we have 4 jobs, and these are the processing time for each job, and this is what is the due date associated with the job. For example, the first job is due at 6, the second job is due at 9, the third job is due at 19, and the fourth job is due at 17. And with this data now, we want to decide the scheduling based on the performance measurement criteria. So let's say we want to schedule it based on the shortest processing time criteria. Okay, so this is what is the data that is given to you, and we are now preparing the schedule based on the shortest processing time, and based on that we will look at these performance measure. Okay, so if you look at here, intuitively you can do it, since it's a small number of job set. So whichever job is having the shortest processing time, that you can process first. So which is the job is having the shortest processing time? It is 3, then 1, then 2, then 4. Okay. So in this way you can prepare it, or you can sort this job using the so for a larger set of jobs even you may use it. So you can see that based on the shortest processing time priority rule, the sequences that you will get is 314, 3124. Now based on this sequence, now we will try to identify, we will try to evaluate the different performance measure. The release time for all the jobs is 0, because before preparing a schedule, all the jobs are available. That means all the jobs are already released for scheduling, they are available, and based on the sequence, then they will be processed. So what will be the completion time for job number 2? Because the sequence is now 3, 1, 2, 4. So the completion time for job will be, it will enter at 0 and it will complete at 2. Okay, so the completion time for the job will be 2. Similarly, the next job in the schedule is job number 1. its processing time is 4. So it will enter at 2 and it will leave at 6. The next job in the sequence is job number 2. It will enter at 6. Its processing time is 7, that it will leave at 13. And the next job is job number 4, which processing time is 8. So in this way, you will find you can calculate the completion time for the job. Now, what will be the flow time for the job? Flow time is the time that the job spends in the system. So job 3 will enter at 0 and it will leave at 2. So what is the flow time for the job? The flow time for the job is 2. Similarly, the next job, that is job number 1, what is the flow time for the job? Because the job has to wait till 6 minutes in the system till it is completed. So the flow time for the job number 1 is 6. Similarly, the next job, that is job number 2, the flow time will be 13. And the next job, that is job number 4, its flow time will be 21, because that job has to wait till all the jobs have been processed. Okay. So this is what is the flow time, and based on that, you may require the mean flow time. So you may be interested, or the objective may be to minimize the mean flow time for the job. So you can identify, or you can calculate the mean flow time. So this mean flow time is nothing but it's an average of.
But the flow time and completion time, both every time will be same, or only in this case?
Flow time means the time at which the job enters the system and it leaves the system.
So if the release time is not 0, which means our flow time will reduce.
Will be different.
Yeah, will be different. So for example, for the second row, fourth row, if we have a release time as 2, which means the flow time will convert to 4.
Yes.
Okay, understood.
Because let's say in that particular case, you have already a sequence of or a schedule for the jobs. And if any job on a priority, if it arrives, then you may enter that job in the schedule. So based on that, it will have a release time. It will be completed, and that will decide its flow time for the job. So flow time is nothing but how much time the job is in the system. And since all these jobs have been released at the beginning, that means the flow release time is 0. The last job will spend till 21st minute. Okay. So based on that, you may have a performance measurement in terms of the mean flow time. You may be interested in what is the maximum flow time for the job. You may be interested in what is the minimum flow time for the job. So you can measure all these performance parameters based on the requirement. So this is about the flow time. Now you can measure the lateness. So lateness is nothing but how do you measure the lateness? It is completion time minus due date. So you can see that the completion time for job number 3, which is first in the sequence. Okay, there are two things. One is sequence and one is job number. So this is what is the sequence. First job will be processed, J3. Second job will be processed, job number 1. Third job will be processed, job number 2. And the fourth job will be processed, job number 4, as per this sequence. So the completion time minus due date. So the completion time for the job 3 is 2 and its due date is 19. So it is minus 17. Okay, because you can see that the job is completed well earlier than its due date. So similarly, you can measure the lateness for all the jobs. And in that case, you may measure what is the mean lateness for the job. So this is what is the mean lateness. This is what is the maximum lateness. This is what is the minimum lateness. Okay. So based on what performance measure you are interested, you can evaluate those performance parameters. Now, the tardiness associated with this particular sequence. So tardiness is nothing but what? It is maximum of 0 and lateness. Okay, so only positive lateness will be considered, because negative lateness, what it will indicate? It will indicate earlier completion of the job. Okay, so as a part of tardiness, we are interested only lateness, because in a situation where there is some penalty that is associated with the positive lateness, in that particular case, we will be interested in how many jobs are tardy jobs, what is the tardiness value, based on that, how much tardiness penalty or lateness penalty will be incurred. So for the first job is concerned, what is the tardiness? It's -17. So if we look at the tardiness value, it's either 0 or positive lateness. So since it is negative, we will take tardiness at 0. Similarly, for second job, what is the lateness value? It is 0. So tardiness will be 0. For third job, the lateness is 4. It's a maximum of 0 and 4, that is 4. And for fourth job, the lateness is how much? It is 4. So it's a maximum of 0 and 4, that is 4 here. So in that case also, you may be interested in mean tardiness or mean maximum tardiness. What is the maximum or the minimum tardiness? Or you may be interested in what are the number of tardy jobs. So how many tardy jobs are here? These two are the tardy jobs. So number of tardy jobs is equal to 2. And if you are interested in make span, what is the make span for this particular sequence?
21.
The time at which the last job leaves the system.
21.
It is 21. So the make span for this particular sequence is 21. So in this way, we try to evaluate the performance of the sequence or the schedule that we prepare. And we may have certain objective in terms of minimizing either the flow time, minimizing either the overtime, whatever objectives that we have seen and that we have already discussed. Okay, so this is how we measure the different performance measure. If you have any doubt related to this, you may ask it.
So how do we improve the tardiness? So now do you have any workout after improvement? How do we do it in the same table for this job?
No, can you repeat the question?
No, there are two tardiness, right? And
now there are two jobs which are tardy based on this sequence.
Yes. So on the job 1 is completed 17 days earlier, so which is not required. So how can we rearrange through Excel?
No, so this is based on this particular scheduling rule, that is shortest processing time. Okay, so it depends on what kind of priority rule that you want to implement. Okay, so you may either utilize the priority rule or there are scheduling algorithms. So
sir, in this case, sir, don't we consider the overlap of processing timing? It means all the activity, if we find, if we can do some jobs parallelly, so in that case, can't we consider that kind of overlap system here? Actually, SPT.
No, means what? See, this is a kind of a situation where you have a single machine, and in that particular machine, you will have to process these jobs. Okay. Now the question here is, in what sequence you should process the job? Because let's say you have 4 jobs.
Yes, sir, understood, sir. For in case of single machine, it will be, and there will not be any overlap, right?
Yeah. So that's what each configuration of the manufacturing shop floor in terms of the way we arrange the manufacturing system. Okay, it may be a floor shop wherein you have an assembly line. It may be a job shop where you have a zigzag flow for the job. Each manufacturing system configuration will have a requirement in terms of different scheduling algorithm and different scheduling requirement. Because if you look at the scheduling problem, if you have 4 jobs to be scheduled, okay, In how many ways you can decide the sequence for the job? If let's say you have 3 jobs,
It's based upon priority.
it may be 1, 2, 3. Ideally, if we are looking at how many sequences are possible, 1, 2, 3, 1, 3, 2, 2, 1, 3,
Will be 6.
2, 3, 1, 3, 1, 2, and 3, 2, 1. So ideally, if you want to decide the schedule based on whatever performance measure that you want to achieve, there are always, so if we have here 6, that is nothing but it's 3 factorial.
Yes.
Okay, if it is a 4 job, that is 4 factorial. So 4 factorial, it will result in 24 sequences. Okay, if you have 10 jobs, then if you have 5 jobs, then 5 factorial, that is 120. So you can see that whenever you have more number of jobs, and if you want to decide the all possible configurations of the job sequences, and based on your requirement of the performance measure, let's say it's minimizing the number of tardy jobs, or it may be minimizing the flow time, or it may be minimizing the completion time for the job. So for that, what you will have to do? Let's say it's minimizing the flow time. What you will have to do? You will have to evaluate all these sequences. For each time, you find the mean flow time, and whichever is minimum, that you select. This is what is the ideal situation. Okay, this we call it as exhaustive enumeration. But when the number of jobs it increases in the manufacturing situation, exhaustive enumeration is not possible. Is it feasible to evaluate 120 job sequence? Is it feasible to evaluate if you go on increasing the number of jobs? 10 factorial, what number it will generate? So that's why it is not feasible to do the exhaustive evaluation, because if you want the best solution for your schedule based on the performance measure, the ideal situation will be evaluate all the possible sequences, measure the performance, and whichever is giving you the best one, select that. But then that is practically not possible. Even computers will have certain limitation in terms of evaluating the algorithm. But this is what is about the single machine. When the configuration of the machines will increase, the complexity of the scheduling problem will increase. So that's why scheduling is a very complex problem as far as the operations planning is concerned. Okay, so that's why we may use certain priority rules. Okay, so whatever priority rule that we have discussed, you can, or we may use those priority rules, but definitely those priority rules will give you certain good measure of the schedule as far as these rules are concerned. So it may be based on the shortest processing time, it may be based on the longest processing time. So what you can do in that case, you may evaluate the schedules based on these priority rules, and whichever rule is giving you the better performance, you may select based on that particular rule. So definitely exhaustively enumerating all these sequences, it's not feasible, it's not possible. Okay, so that's why in manufacturing, either you can use these priority rules, or then you will have to use the scheduling algorithms. I hope this is clear, the complexity of the scheduling problem.
Yes, sir.
Yes, sir. Yes, sir.
Sir, what about the scheduling in a continuous process plant, petrochemical plant, or refineries? How they schedule? How? Any idea?
Related to it's scheduling of what?
Scheduling of their individual process, their individual continuous process, because they have all the continuous process. Now in continuous process plant, they have some units and the continuous process is there. So the this matlab, So individual scheduling of the process, I think not possible. So how they manage large scale process plant, large scale petrochemical plant? They also do the schedule of the unit process or some whole process.
Though
I
that
think
will be
I think
adjusted by the capacity. Okay, that will be adjusted by the capacity.
Suppose the
How much
capacity is
output they want to achieve.
suppose the capacity is 1,000 ton per day. 1,000 metric ton per day. So they schedule they schedule, I think, based on their capacity, how the throughput maybe change, how they measure the performance of scheduling based on the capacity, I think. If the
Yeah, that
capacity
is
is
based on the
coming
capacity.
down, so they come back, why this is coming down, what is the
How do you
scheduling
measure the
failure, what is the
capacity?
unit operation.
So it depends on the capacity of that particular plant. For example, in case of a steel plant, how much tons of steel that the particular plant is able to manufacture, isn't it? For a textile industry, it will be based on how much meter or the rolls that can be possible based on that particular capacity of that particular plant.
Okay.
Okay, so this is about the shortest processing time. We may have other performance measure like an earliest due date. So in that particular situation, you may prepare the schedule based on the earliest due date criteria. So based on the earliest due date criteria, you may prepare the schedule. So this is what is the processing order based on the earliest due date criteria. Because when you are looking at a scheduling problem for a number of jobs that you have, if you want the best performance job, use the exhaustive enumeration, but then that is not feasible. Okay, when the number of jobs will increase, that will not be feasible. So in that particular situation, you may come up with, or you may use these priority rules. But of course, these priority rules will also not give you a good performance. So in that case, you will have to use some other algorithms or other techniques. Okay, so we'll discuss about few of those techniques also. So
I have a question, sir. So far in this program, we have started from how to do a design of a layout, and from there we have come to a scheduling part. So how the schedule should be considered? Or is there any correlation for layout sizing, or it is only a short-term activity without considering the layout? This can be handled.
Okay, so we have discussed about the lived-in layout. Okay, it's a process layout or it's a product layout.
Correct.
Isn't it?
Yes.
So a process layout will have a different scheduling requirement. For example, in the case of a job shop, the same algorithm you cannot apply in case of a job shop. Whatever algorithm that exists for a single machine, the same algorithm cannot be applied in case of a flow shop or even a job shop. That's why if you look at in one of the slides, I mentioned that so when we are looking at the scheduling context, we have to look at number of things. Okay, it may be the number of jobs. So you can see that when the number of jobs it increases, the scheduling complexity increases, because if you want the best schedule, you will have to exhaustively enumerate all the possible sequences. That is not feasible. Even it depends on a number of machines. So here we are considering only single machine, but when the number of machines will increase, that will increase the complexity. Even it will vary with the configuration of the shop. So whatever layout that you have planned, whether it's a process layout, whether it's a product layout, whether it's a group technology or cellular manufacturing, or whether it's a parallel machine situation where you have a number of identical processing stations at which you can process the jobs, your scheduling algorithms will, or scheduling rules will change. Okay, so when you are looking at all these scheduling problems or scheduling aspect, you have to look at the different configuration. So whatever layout that you have prepared or layout that is planned, the scheduling will work as per, or scheduling has to be implemented as per the configuration in which you want to process the jobs.
And these all performance scheduling rules, sir, whether that can be implemented or any specific can be suited for this organization, how we need to suggest is performing all can be implemented, or any at least like first in first out or last
No,
in
all
last
can
out?
be implemented. All can be implemented. For example, if let's say if the service aspect or the delivery aspect is more important, okay, you are in a situation where you don't want to miss the delivery date. So in that case, it may be a completion based criteria. So the schedule you will prepare based on meeting the due date. Okay, for example, you are a vendor of some OEM. Okay, and if it is a new order that you have received and you don't want to miss the delivery date, so in that situation, the objective may be to minimize or to meet the due date, isn't it? If it is a kind of a food processing industry wherein the shelf life of the product is more important, otherwise by the time the job is processed, the raw material is spoiled. So in that case, flow time will be important. So you have to decide the performance measure, and based on the performance measure, you have to prepare the schedules so that whatever performance measure that you want to achieve or fulfill, the schedule should fulfill that particular performance measure. Because when you have prepared a schedule, let's say 1, 2, 3, 4, how you will evaluate that schedule, whether it is meeting your requirement or not.
Yeah, correct.
So these are the performance measurement criteria. It may be a flow time, it may be a make span, it may be a completion time, it may be a mean flow time, it may be a maximum flow time. So it depends on what are your business priorities, what are your other, you can say, terms that are related with the orders that you want to process.
And also how we can handle these special cases, sir, because we are those two last, maybe can you go to the previous slide, those two cases are having a very tardiness. So if the
in this case, this particular sequence is giving you these number of tardy jobs. So maybe in that case, if you don't want the tardy jobs, in that case you may process it based on other priority rule.
No, sir, I stick with the SPT model only, but the 2-3 process, they need some quick turnaround. So can we, any other suggestion like, to improve that? I want to go with SPT only, but seeing the order, I could able to, quickly complete it, or at least that tardiness can be reduced.
These values that will be based on the sequence in which it will be processed. You cannot change the processing time. Can you change the processing time?
No.
You cannot change it, okay? Because that processing has to be involved. It will take its time.
Okay.
Okay. So maybe in a situation, if it is possible to split the job, in that case, you may do it. But that is not possible because you cannot eliminate the processing time part of any job. Because the sequence will decide, or the start or finish time will be based on at what time the job enters the system and at what time the job leaves. That will be based on how much is the processing time for the job. So in that case, you may have to use a different algorithm that will give you the better sequence. So if you change the sequence, your objective may get fulfilled. But then how you will decide the sequence? So you may have to use either priority rule, or you may go with certain other algorithms. Okay, so that is what is the importance of understanding the scheduling and its importance in the overall system. Is your question answered or not?
Yes, yes, sir. Because now we are only seeing one
This is
one
just
flow,
one sequence.
one sequence,
This
but
is just one sequence.
Yeah.
If you have a 4 jobs, there will be 4 factorial. That means 24 sequences are possible.
correct, correct.
Out of those, because since 24 sequences is not possible to evaluate, okay, in a situation, if you are able to evaluate, you can evaluate, and based on that, you may select it. But let's say you have a 10 jobs. In that case, you will have to use some scheduling algorithm to get the best schedule. So these are some of the priority rules which are used in industries, and based on that, you may get some sequence in which you will process the job. Otherwise, let's say you have 10 jobs, how you will decide in what sequence you will process it? So
Maybe
these are some of the rules.
correct, correct.
These are some of the rules by which you can decide the order in which you will process the jobs. And based on the order, the priority rule that you have selected, you may measure the performance of the jobs.
Sir, any other maybe priorities can be included here about whatever we discussed here? Sometimes customer priorities will be there, which we didn't cover. Maybe like high priority based on the, maybe he might have given late order, but SLAs will be there, right? Minimum SLA for this quantity to be delivered on 30 days or 20 days. So how that can be, incorporated in this scheduling?
It will be early due date scheduling.
So it may be based on the earliest due date, because if it is a priority, if that order is having a priority, that means that has to be completed earlier, isn't it? For example, if you have any rush order that you have received, okay, so in that case, you may consider it as the earliest due date, and maybe based on that, you can prepare the schedule.
So when we are defining the values itself, we have to consider, and then we need to go for this scheduling.
These particular rules. Yes,
okay,
yeah.
got it.
Okay, so this is based on the earliest due date criteria. So whatever job is having the earlier due date, you may use that particular sequence, that particular rule, and maybe based on that, you may evaluate the different performance measure, and based on the rule, whichever performance measure that you want to calculate, you may calculate it. So I hope this is clear. The only thing here is that the sequence is based on this sequence, processing order 1, 2, 4, 3 is based on the earliest due date criteria. Okay. So for example, here you can see that whatever jobs that you have, you may process it based on the earliest due date. So you may sort the data maybe based on the due date, and whichever job is having the earliest one. So the sequence is what? Based on the earliest due date criteria. It is 1, 2, 4, 3. So in this order, you will process your jobs. And based on that, you may evaluate the performance of the different sequences. So you will evaluate the different performance parameter like flow time, lateness, tardiness, and so on and so forth. So here you can see that the mean tardiness is 1.5, whereas in case of a shortest processing time, what is the mean tardiness? It is 2. Okay, so maybe based on this, if you are more concerned with the number of tardy jobs, so for example here, for the same problem, the number of tardy jobs are 3. And as per the SPT rule, the number of tardy jobs are 2 only. So in a situation where you are looking for less number of tardy jobs, you may use the earliest due date criteria. So it depends on your objective, and accordingly you may use the priority rules to decide the schedule or prepare the sequence in which you will process the jobs. So for each priority rule, then you may evaluate its performance, and based on that you may select the required sequence. Is it clear? If any doubt related to this? Okay, so we have already discussed about the flow time. So let's say there is some penalty that is associated. So the penalty is nothing but it's a weight. Okay, for example, you have 4 jobs, and let's say each job is having certain weight in terms of the importance. For example, if job 1 is delayed, it will have a penalty of some value. If job 2 is late, it will have some penalty. So in a situation where you have the weighted the weights, that is the penalty that is associated with the job. So in that case, if you want to minimize the or decide the sequence in which you will process the job, so that will based on this rule that we call it as WSPT. So it's a weighted shortest processing time. So you will evaluate or you will estimate the mean weighted flow time, and the mean weighted flow time is nothing but it's the summation of the weight multiplied by the flow time for the job. Divided by the summation of the weight. Okay, so this weight is nothing but it's an importance, it's a penalty. So for example, if you have different orders, and if these particular jobs or orders, they have a different penalty, so in that case, this will be reflected by the weight or the penalty that will be associated with the job. So the jobs will be sequenced as per this WSPT sequence. So what you have to do here, you have to divide the processing time of the job by its weight. Okay, and then you have to, because in SP2 rule, what we do, we decide the sequence based on the shortest value of the processing time. Here you have to decide the weighted shortest time, and that weighted shortest time you will evaluate based on T by W, that is the processing time divided by its weight, and based on that value of the weighted processing time, you will process the jobs. So let's say we have 5 jobs, and for these 5 jobs, these are the processing times in hours, and let's say each job is having a penalty, that is weight. So the penalty for job 1 is 1, the penalty of job 2 for 2, the penalty for job 3 is 1. So for simplicity and for understanding of the calculations, we have taken a lower value. So if we want to decide the sequence in which we have to process, so first what we'll have to do, we'll have to find the weighted processing time. So these are the weighted processing time. So weighted processing time is nothing but processing time divided by the weight. For example, job 1, the processing time is 15 and its weight is 1. So its weighted processing time is 15. For job 2, it is 4. The weight is 2, so it will be 4 by 2. So for job 3, it is 5 by 1. It is 14 by 2. And this will be 8 by 3. And then you have to arrange the jobs in a, so it's the shortest processing time, but then you have to take the weighted shortest time. So what will be the sequence for these jobs? Whichever job is having the lowest weighted processing time. So in this case, it will be job number 2, then job 3, job 4, then job 3, So as per the weighted processing time, what is the shortest time? Here it's 2. So it is for job number 2. So it will be J2. Then the next job is J5. Then the next job is J3. Then the next job will be J4. And the next job will be J7. So in this way, you will process the sequence, and based on that, you may calculate the mean flow time, that is the weighted flow time. So in that case, you can estimate the flow time for the job, that is nothing but, so this is what is the sequence now. So you will process the job in this sequence 2, 5, 3, 4, 1, and your weighted flow time will then become weight multiplied by the flow time. And flow time is nothing but what? The time at which it enters the system and the time at which it leaves the system. So for job number 2, its processing time is 4, so it will be completed by 4. So flow time is 4, and its weighted flow time will become 4 multiplied by 2, that is 8. Similarly, for job number 5, its processing time is 8. It will be completed by 12. Its weight is 3. So what will be the weighted flow time? It will be 12 multiplied by 3, that is 36. So in this way, you will estimate the weighted flow time, and the mean flow time for that particular case will be the summation of the weighted flow time divided by summation of the weights. So in this case, the weighted flow time will get to this value. So in a situation where you have a penalty or the weight that is associated with the job, you will have to use the WSPT rule instead of the shortest processing time rule. Okay, so this we have already discussed that whenever we are looking at the scheduling problem, the ideal requirement is that we have to schedule n possible sequences. Okay, that means this is an n factorial, which is called the exhaustive enumeration. So practically exhaustive enumeration is not feasible. In that case, we have to use certain algorithms. Okay, so those approaches are called the heuristic approaches. So there are different heuristic approaches that can be utilized for the different scheduling problems that we can solve. Now we will look at the multi-machine case, wherein we have a flow shop kind of a situation wherein the jobs are arranged in the series or the sequence. For example, in case of an assembly line where you have number of workstation, and in that particular situation, the job has to process through the different workstation. So let's say you have n jobs that are to be processed through that particular series arrangement, that is called the flow shop. Now the question here is, in what sequence you will process the jobs through this particular flow shop. So let's say for the manufacturing industry, let's say car industry, if they have 10 variants and each variant will have a different time. So in that case, if it has to process through a sequence of the workstation, in what sequence they should process the jobs or they should assemble the cars. So in this particular situation, we have to use a different algorithm. So Johnson rule or Johnson's algorithm is a classical algorithm which is utilized in many situations in case where you want to prepare a schedule in case of a flow shop situation where you have number of jobs to be processed in a fixed sequence which has to go through the different machines. Many of you have turned off your videos, okay? So I don't want to talk in front of a black screen. So I hope at least from the previous discussion, you have to some extent understood the complexity of the scheduling problem. And based on that, how we can utilize the different performance measures in scheduling situation. And based on that, what is the need for the scheduling algorithms, because we cannot implement the scheduling in terms of any random situation in which we can schedule the jobs on the machine, because that may affect the performance measure. And because related to each performance measure, whatever the drivers that are associated with any business, those will get affected. So in that particular situation, we have to utilize the different scientific methods which are available, different algorithms which are available for the scheduling, or we should use the scientific approach for the scheduling problem, so that certain performance measure can be fulfilled, which will result in achievement of the key business objectives related to any manufacturing industry or any business organization is concerned. So ideally, you can prepare a schedule, or the scheduling decision can be based on exhaustive enumeration, but that is not feasible. So to get a quick solution, you may use priority rules. For example, you may use the SPT rule, LPT rule. Based on that, you can measure the performance, and depending on which rule is giving you the better performance, you may select the sequence based on that particular priority rule. But of course, priority rules will also not give you a better solution. For that, you need to use different algorithms. So if you have a flow shop situation wherein the jobs have to be processed in a fixed sequence, so in that case, Johnson's algorithm is a classical algorithm which is available. So these algorithm steps are being given. So we will try to look at from the example. So what this algorithm, it says that, let's say we have a 2 machine situation. So let the job, 6 job has to be processed through a set of 2 machines. First, the job will go on milling machine, and then the job will go on the grinding machine. And these are the processing times on each machine. So the processing time on milling machine is 15. The processing time on grinding machine is 3. So these are the processing time. Now the question here is how you will decide the sequence in which these jobs have to be processed. Okay. So for that, then the Johnson has given the rule. So as per the Johnson rule, what it says that you have to look at the processing time on machine 1 and machine 2. If it is on machine 1, so we have here 6 jobs. So this is what is the sequence. So if the processing time is on machine 1, it has to be processed from the beginning. Okay, you have to put it at the beginning of the schedule. And if the minimum time is on machine 2, you have to process it at the last in the sequence. Okay, so if minimum is on machine 1, you have to process it from the left. That means you have to put it from the left of the sequence. And if the minimum is on machine 2, you have to put it from the right. That means you have to put it at the end of the schedule. For example, in this case, the minimum is, how much is the minimum value? It is 3. So that is on machine 2. So job number 1 will be processed last. So this will be J1. Similarly, that means J1 is processed. So this is done. Then you have to find again the minimum of the remaining processing time. If it happens on machine 1, you have to process it at the beginning. If it happens on machine 2, you have to process it last on the sequence. So in this case, the next lowest is how much? It is 5. This is for, again, job number 3 on machine 2. So the job 3 will be processed at the next level. So this is also done. Again, you find the minimum from the remaining. Now this is 8 for job number 2 and job number 4. So in case of a tie, you can break it arbitrarily. So let's say we will select this one, which is job number 2 on first machine. So job 2, since it is on first machine, we will process it at the beginning. Okay, so in this way, you will keep on assigning the jobs. So then job number 4. Then
Can you repeat, sir? Little confusing. For assigning the jobs, like.
so you have to find the minimum of the processing time if it happens on machine 1. So this is machine 1. This is machine 2. If it happens on machine 1, you have to process it at the beginning of the sequence. Okay. And if it happens on machine 2, you have to process it at the last. So the lowest value is 3 here, which is for machine 2. And since it is on machine 2, we will process it at the last. So job 1 will be placed at the last in the sequence. Okay. That means 6 job will be processed, will be job 1. So this job is done, or the sequence is, it is put in the sequence. The next job is you have to find the remaining time and identify the minimum one. So what is the minimum value here? 5. Okay, so now this is again on machine 2. So the next job will be job number 3. So the decision is based on the processing time, on whether it is on machine 1 or machine 2, and accordingly you have to put it in the sequence. So this is what is the sequence in which you will process. So 5 processing time is less or minimum for job 3, and since it is on machine 2, we will put it in the last in the sequence. So in this way, you will keep on assigning the job, identifying it from the remaining unassigned jobs, and based on whether it is in machine 1 or machine 2, you will process it in the sequence. So based on that, you will see that the sequence will get to J2, J5, J6, J4, J3, and J1. So in this way, now you will process the job in this particular arrangement of the 2 machines in sequence. And based on that, you may find the make span time. So if you want to find the make span time, what you need to do, you need to find the start time and finish time for the jobs. Okay. So this is what is the sequence. For example, the processing time for job 1, job number 2 on machine 1 is how much? It's 8. So it will start at 8, it will finish at 8. And then it will go to machine 2. So it will start at 8 and its processing time on machine 2 is 20. So it will finish at 28. So in this way, for each job in the sequence, you will find the start and finish time. For example, here you can see job number 6. It will start at 25. It will complete at 48, 47. Okay. But is machine 2 free at 47? Because earlier job will complete at 48. So since the machine is not free, the job will enter when the machine will get free. So here it will enter at 48, and based on that it will be completed. Okay. So when you are finding the start time and finish time, you have to look at whether for the next job machine is free or not, because the job will be processed in that particular sequence only. So in this case, in this way, you will process the jobs in this particular sequence, and based on that, whatever the time, the last job will leave the system, and that time we call it as the make span time. So in a situation where you have a number of jobs that need to be processed in case of a multiple machine, you may be interested in knowing the performance measure that we call it as the make span. So in this particular case, your objective may be to minimize the make span time for the job, and accordingly, you will have to decide the sequence. So scheduling in case of a flow shop, because you can see that there are 6 jobs. So there will be 6 factorial combinations possible. Each combination, each sequence will result in a different make span. So in this case, you will be interested in which sequence you will select, that will be based on this particular Johnson rule. So as per this Johnson rule, the make span time, this particular sequence will be 108.
Sir, suppose the finish time for machine 1 is more compared to start time of machine 2. Then we need to take machine 1 finish time as a start time for machine 2, or how it will be like?
See the sequence in case of a flow shop manufacturing or in case of a mass manufacturing, the sequence is fixed. So that is what is the characteristic of a process, the product layout. Because product layout is prepared based on the fixed sequence of the jobs. For example, if it is a car that you are assembling, you cannot assemble the you cannot have a wiring or the harnessing before the headlights are put up. Okay, because you will have to assemble it. Okay, so that particular sequence you cannot change. So in this case, you will be interested in knowing that what should be the make span time for the job, and that will be based on the sequence. So in a situation, if the machine is not free, then the machine will have to remain idle. So in this particular situation, the objective may be to minimize the make span, or in other situation, it will be to minimize the idle time of the machine. And with that objective, when you will solve the problem, it will be resulting in a different schedule. Okay, so in that particular situation, your objective may be to minimize the idle time, because each sequence will have a different make span, will have a different idle time associated with the machine. And depending on what objective you want to fulfill, you will have to solve that particular scheduling problem based on that particular requirement. I hope the make span time calculation is clear here. Okay. So in that situation, you may be interested in knowing what is the job idle time, what is the machine idle time, and based on that, you may have your the priorities in terms of deciding the algorithm. So of course, in case of a flow shop manufacturing, Johnson's algorithm will give you a good sequence, but of course, there may be another algorithms that may give you a better performance than this algorithm. So this is about the 2 machine case. We may have a 3 machine case. So in that situation, the 2 machine problem is first converted into a 1 machine problem. Okay. So what is being done here? The processing time of these 2 machines is clubbed, and it is considered as machine A or machine 1. And the processing time of second and third machine is added, and that is considered as a machine 2. So a 3 machine problem is converted into a 2 machine problem, and then whatever steps that we have discussed for a 2 machine problem, based on this, the sequence is decided. Okay. For example, here the problem is converted into a 2 machine by adding these 2 times. So for example, for first job, it is 15 plus 2, 17. And for second machine, it will be 2 plus 1, that is 3. So the problem is converted into a 2 machine case. And based on that, first, the sequence is decided. So based on the steps that we have discussed, the sequence will be 2, 6, 5, 4, 3, 1. Okay. And now to find the make span time, then you have to again go back to your original problem. So this 2 machine conversion is just for deciding the sequence. Okay. And again, then you have to go with this sequence. You will go to machine 1, machine 2, and machine 3. And then you can find the start and finish time, start and finish time, start and finish time for each job. And based on that, you will have to find the make span time, as we have done it in case of the 2 machine problem. Okay. So make span time, when it will involve, you have to consider all the 3 machines. Only for deciding the sequence, you will convert the problem into a 2 machine case. and based on that, you will then decide the sequence. Once sequence is obtained, because the job has to process through 3 machines, you will have to prepare for the particular sequence, that is 2, 6, 5, 4, 3, 1. And it will be machine 1, machine 2, and machine 3. And each machine will have a start and finish time for the job. Start and finish time for the job. And based on that, at whatever time the job will leave the system, that will be the make span time for that particular sequence. Okay. Of course, when the number of machines will increase, there are different algorithms that are available. So let's say when you have n jobs and m machine, there are algorithms. One popular algorithm that is called the CDS heuristic. Okay. So as we have seen that in case of a multiple machine problem, or even when the number of jobs it increases, you have to use different scheduling algorithms or the heuristic algorithms, which will give you a better solution in terms of whatever performance measure that you want to identify or estimate based on the scheduling problem that you are considering. Okay, is there any doubt related to this? Otherwise, we'll stop here at this point. The process layout scheduling, that means the scheduling related to the job shops, we'll discuss it in next session.
Sir, I have only one doubt. When we convert that 3 machine to 2 machine problem for Johnson's algorithm, why do we add machine 2 twice, 1 to machine 1 and 1 to machine 3? If it is clustered into one machine 1 and 2 are clustered into one machine, and we are adding the time, I understand that. But again, doing it with 3, I do not understand the logic.
This one?
Yeah, machine 1
so
plus
see,
machine 2, machine 2
you
plus
have to
machine 2.
convert it as a kind of 2 machine problem. Okay.
Yes, sir.
So the first machine, that is machine 1, let's say, so M1 and M2 processing time, if you add it, that
Yes,
will
sir.
become your machine 1. For machine 2, you add M2 and M3, that you consider as a machine 2. And then whatever steps that we have looked at, you may apply to these 2 machine problem. Based on that, you can decide the sequence. And once you have got the sequence, you have to again get back to your original problem of 3 machines, because the job has to process through 3 machines. And based on that, then you will find the make span time.
Sir, I understood the procedure when you explained, but I did not understand the logic why machine 2 is added with machine 1 as well as machine 3 instead of only once.
So just to convert, because we want to, because the initial algorithm is available for a 2 machine case only. So we are just converting that into a 2 machine problem.
Yes, sir, I understood that concept, but why machine 2 is added twice, that is with machine 1 as well as machine 3? Why not machine 1 and machine 2 first and machine 3 kept separate? Why machine 2 again added with machine 3?
You may use that also. Okay, you can try, but then in that case, you will get a different sequence maybe, and based on that, you may compare. Because see, in any scheduling problem, okay, that's why I explained you the complexity of the scheduling problem. It is not feasible to evaluate all the schedules. So you have to find some means by which you can get some better sequence. Okay.
Yes,
so this is a nothing, it's a kind of a heuristic, which is a kind of experience-based approach. Heuristic is nothing but it's an experience-based approach.
Okay.
So he is using some, because otherwise if you use the random principle, it may happen that you may come with the worst schedule. For example, your objective is to meet the due date. And if you have randomly selected the schedule, it may happen that all your jobs will become late and you will miss all the orders of your customer. So definitely when you use some algorithm, some heuristic process or some priority rule, you will get one of the better solution, because whatever sequence that you will get, it will be one from all the possible sequences. And definitely whatever rule that you are applying, it will result in some kind of a better solution. Because in real life situation, to get the ultimate best out of n factorial sequence is not possible. That is what is the complexity of any scheduling problem.
Okay, fine.
Okay, so even if you consider that way, that if you club machine 1 and machine 2 and machine 3 as a separate by converting this as a two machine problem, and based on that you decide the sequence, you may get a sequence, you may evaluate that particular sequence, you may compare it with the Johnson, and whichever is the better one, you may select it. Because ultimately what will be your objective in that case? You want a sequence which will minimize your make span time. Isn't it?
Yes.
Yeah. So whenever
Okay.
these algorithms they are implemented, their performance is compared. Okay. And which algorithm is giving the better performance, those algorithms are selected.
Okay.
Okay.
So it's an experience-based approach out of which this has already been proved out methodology.
Yes, yes. It's a proved methodology. It is being tested with a lot of research is being done. And based on that, they found that if you club this, that will give the better solution. The basic point is that we have to convert it as a two machine problem. And based on that, because when it's a multi-machine problem, the complexity is very high. Okay. And for higher number of machines, there are other algorithms. Okay. Which are based on the Johnsons. For example, the CDS heuristic is one which is called. So there are so many approaches because a lot of research goes on. People apply their experience, people come up with some mathematical tweaking, they come up with some algorithm, and based on that, they evaluate its performance by comparing with other, and based on that, gets a kind of an acknowledgement whether it is giving you a better performance or not. So these CDS is one such algorithm which is used for n job m machine, but which is based on the Johnson's algorithm only.
Thanks.
So you will find that many approaches. As a part of this, we are trying to understand the basics behind the scheduling and how we do it in terms of some preliminary level, so that maybe at a higher level, if you come across, maybe you can utilize this fundamentals concept, and maybe you can utilize some algorithms for achieving the required performance measure, maybe related with your organization.
Okay.
Okay. Is there anything? Okay, then. So we stop here for the today's session. In next session, then we will continue with the job shop, which is even more complex. Okay. So even if we look at the single machine problem, itself is a complex problem when the number of jobs it increases. But in case of a job shop where the complexity is very high, because each job will have a different processing or the work center requirement, each job will have a different position in the sequence, and each job will have a different processing time. So there are 4 elements which we have to incur or which we'll have to include in the scheduling problem, and based on that, how we can prepare a schedule, that we will discuss it in next session. Okay. Okay, so we stop here. Okay, thank you.
When this marks will be released, sir? This marks.
Yeah. Maybe today or maybe by tomorrow.
Okay.
Okay, sir. Thank you.
Thank you.
Okay, then. Thank you.